Hi, we're just about to start the meeting on the Apex cycle for the Kubernetes IoT Edge working group. As always, the conduct of this group and this meeting are governed by the Kubernetes Code of Conduct. So be nice to each other. This meeting is public, recorded, and will be posted to YouTube. So if you're not prepared to get recorded, you can drop off now. With that said, let's get started. We had two items on the agenda. The first was Tina giving a presentation on the Acrano project, but she isn't here yet, so we'll just leave that for now, and hopefully she'll show up. Then the second item on the agenda is me giving a presentation about running apps at Edge. And what this is Kilton Hopkins, who maybe he'll join us, specifically asked for coverage of this. And Cindy, the co-chair, and I are about to prepare a presentation for the online KubeCon Europe event. And the agenda for our presentation is specifically on running apps at Edge. So I'm going to use this as an opportunity to test some material that I'm thinking of putting in that KubeCon presentation. So if you as an audience would give me an honest and review if it needs work or isn't even what you know, if you think I should substitute it for other material, please let me know before I go on in front of the broader audience. But I'll put it up and understand that I just put these slides together all the way up until 15 minutes before this meeting started. So I'm still working on them now. So they're potentially pretty rough, but I think the important thing maybe isn't the polish on the slide deck, but the actual content. So with that said, let me set up sharing in just a moment. Okay, I think you should be able to see a title slide for a section of my deck.
Yes.
Okay, so applications at Edge, some characteristics. And I won't show it to you, but because I know that you're not likely to need it, but for the KubeCon audience, I'll go into sort of a slide with all the different use cases at Edge, you know, anything from device edge to gateway edge, etc. I'm going to just skip that tonight. But in my mind, one of the biggest considerations for from an app perspective with Kubernetes is, you know, does it go low enough, as portrayed by the limbo bar here? What do I mean by does it go low enough? Well, I put together this drawing that on the right side shows different classes of apps, and on the left shows different classes of compute hardware that you might be running it on at Edge. So obviously, if Edge to you is something like there are places that are going to run a half rack of equipment, and they're pretty much server, you know, full rack mount servers, it ends up being, you know, that's an environment where your apps are packaged in containers, and Kubernetes should have no issue with whatsoever. Where this becomes an issue is when you get down to things like equipment the size of Intel NUCs. I'm not trying to plug one particular vendor here, but that's perhaps the best known one in its class where I live. And the NUC is a system that might have as little as 4 gig of RAM, 4 cores, the Raspberry Pi 4, I guess they recently announced one that goes up to 8 gig. But when it first came out, those things were, I think, 2 and 4 gig systems. So that would be kind of a top of the line for some edge deployments. You drop down a little lower. I haven't heard of people actually using it, but I'm not sure why. But a mid-range cell phone, I happen to just randomly pick a Samsung S20, so it's not a flagship model, but just kind of a mid-priced one, at least for the US consumer market. And that device has 3 gigabyte of RAM. It actually has 8 cores, so a little more than a Pi and the low tier NUC systems. Once again, I don't think they're commonly using literally cell phones at edge, but you could easily build hardware that is modeled on that same framework, and the price point is attractive. An actual cell phone might actually be attractive simply because the battery in the thing is equivalent to a UPS, and it would already have a 4G or 5G capable radio. Going further down the stack, you've got the Pi 3, which is only 1 gig of RAM, and even further yet, the Arduino, which is something that doesn't even run Linux or an operating system at all. Going over to the right side, you've got different platforms that host apps, and then of course the apps themselves. So starting at the top, I think that hypervisors generally are out there citing a minimal requirement to make sense of 4 gig of RAM. I think they could probably go a little bit lower, and I think the 2 models that I looked up on that 4 gig spec were, my own employer has one called vSphere, but there's an open source project called Acorn. I believe they're both citing 4 gig. Once again, I think you could go lower, but you need to have enough left out around after you load the hypervisor to make it worth the bother. And worth the bother is probably running at least 3 VMs. I mean, if you're only going to run 1 VM, one might question the value of the hypervisor. So you really need enough to make a multiple VM scenario practical. You've got Kubernetes variants, anything from, I think the one that may cite the lowest memory requirement is K3S, where their documentation actually says it's capable of running in 512 megabytes. Now, whether that's a practical production grade thing, I don't know. I'm skeptical. It may be something that's more along the lines of, yes, it booted, I can run Hello World, and use it as a learning platform to learn kubectl commands. But it strikes me that if you look at the other things on that chart, the Ubuntu server operating system and the Docker runtime both also quote 512 megabyte minimals. So, if you're going to load a Kubernetes on top of that, what do you have left to run your containerized apps? Probably very little. Yin, you're on the call, but I think the current KubeEdge docs suggest 4 gig as a recommendation, if I'm not mistaken. MicroK8s is sort of in between there, where I believe they say 1 gigabyte. And I personally have installed MicroK8s and K3S on Raspberry Pi 3s, and I can verify that they definitely boot up. They don't have a whole lot left for running a whole lot of containerized apps, but it is fair. I have personal experience where I can verify they will actually run.
Sorry, I don't want to interrupt. Do you want to ask a question now or later?
Sure, go ahead.
Yeah, I just say the KubeEdge we can boot up at 250 meg.
Okay.
For the recommendation. The footprint of KubeEdge on running on Edge is take about 40 to 70 megabytes, depends on your deployment. you can choose more stuff. It's up to 70 megabytes footprint on the edge. If you want the minimum, it's about 40 megabytes.
Okay, so you think you could run on certainly a Pi 3 then?
Yeah, we did. I mean, all this example in the GitHub, there's in the github.com kubeedge/examples. There's a lot of LT examples, traffic light, or
all right.
Yeah, that's only take. Yeah, that's only at that time the only Pi 3, Pi 4 is not up for sale yet.
Yeah.
So that's run on Pi 3 with a 1 gig memory. And
thanks. I'll clarify that when I go on with the presentation, assuming I keep this material.
Yep.
And then looking at that app stack, you see a few other variants that are probably potential solutions already out there now for what I call sub-Kubernetes, maybe sub-Docker. Some of the Java runtimes are capable of running in 256 meg. And those Java runtimes have been out there for a decade or more in the embedded space. So there already is stuff out there like that. If you go down to compiled languages, compiled C, C++, Python, and there are people who have tools that'll even allow you to compile Java as opposed to running it with a JRE from bytecode. And that stuff is capable of getting pretty small. Some of it hostable on platforms like the Arduino. And Kubernetes out of the box just is not going to manage those. So the point being, can Kubernetes go low enough? Now, a solution to that is to go with the CRD model then, something which KubeEdge did. So potentially you can have Kubernetes just standard out of the box, no extensions whatsoever, managing containerized apps where those make sense. Clearly they make sense in large clouds, but also at regional and mid-tier, maybe even gateway nodes, if those gateway nodes are pretty sizable, in the 4 gig of memory class. But there is some point where Kubernetes just isn't going to go low enough, yet there is still the potential to use it as a control plane if you were to implement CRDs for managing these sub-containerized apps. But even if you take Kubernetes and take it with the CRDs to manage it, Kubernetes alone doesn't really solve all the challenges you've got. And some of the challenges I'll list here are, how do you actually get the applications to the edge? Registries can do this. Things like the Harbor project can do Docker images, but there's potentially other things you need to get to edge as well. Things like your OS images. If your Kubernetes node runs on top of Linux and Linux needs a security patch, how do you get the updates to Linux out to those edge nodes? How do you monitor and manage the health and the updates and the different aspects of the hardware and the OS that Kubernetes is running on, device drivers, firmware? How do you even, for a lot of these edge use cases, additional work is going to be the provisioning and onboarding of new nodes. If you're using OSs and hypervisors, they're going to have drivers, and those, in my experience, are always going to need updates. There's there's the cost of initial provisioning, but then there's the day 2 and beyond cost of maintaining those. And if you don't maintain them, you're potentially running up against huge security risks. Oops, I just hit advance a little too soon. So we'd like solutions to manage status reporting of the things that are under Kubernetes. And of course, you've got tools in the CNCF landscape that can do this. if you install the proper reporting and observability features down on these lower tiers. And I believe that that stuff is available, but it might require today a little bit of work on the part of the users to go discover it and manage it in parallel with Kubernetes. And this group has often discussed the security aspects and even have a white paper about things, the challenges of managing unattended nodes where you don't have physical security. I'm going to move on now to take on the topic Kilton wanted to hear discussed, and that's serverless at edge. You know, Amazon has a web page talking about their Lambdas in use for edge applications, and I cut and pasted this diagram that uses sensors on a tractor feeding into Amazon Kinesis, triggering a Lambda and outputting some result or processing some result. And this example appeared to me when I read it to be one where you're doing serverless at edge, where the data is created at the edge, but feeds up fairly quickly into the AWS public cloud. There are also scenarios where that data just stays out at the edge and never goes up to a public cloud. What about that? Now, in fairness, Amazon also has a page on Amazon IoT Greengrass, and this solution appears to be a physical appliance that takes data feeds out at edge, potentially does execute Lambdas on the appliance, and maybe from there continues to feed up data streams up to the public cloud systems and Lambdas or to S3 storage. I saw that in some of those examples. But, you know, this is an open source group, and what if you wanted to stage serverless yourself at edge? What would that look like? Is it feasible? Well, let's evaluate some of the key elements. You know, and here I've gone and I've cut and pasted some text from the AWS Lambda marketing materials. And I'm not using Lambda here to pick a favorite. It's just that in my experience, it's the best known example. Other cloud providers like Google have their own version. For example, Google Cloud Functions are, at least in my mind, something pretty much like AWS Lambdas. So I'm picking on Lambda, but it's just because, like I say, I think it's the best known. But we look at that quote, and it says it's a compute service that lets you run code without provisioning or managing servers. It executes the code only when needed, scales automatically, and no charge when your code's not running. Now, you've noticed that I've color coded it. It wasn't color coded like this when on the web page that I got it from. And no, it didn't end up all colorful because I had a bunch of kids sitting at home because of COVID who broke out the crayon box. I did this because the green things make sense to me. Obviously it runs code. Well, pretty much any app solution is going to run code. But the ones in red struck me as maybe not actually being valid or making sense. When you're talking about standing this up at edge on your own hardware. You know, it says it lets you run code without provisioning or managing servers. Well, if I'm going to stage it, I do own that server. You know, and if I already paid the CapEx on buying that server and staging it, in a sense, the part about no charge when not running doesn't make sense. You know, I effectively already bought it, whether it's running or not. The yellow part is true. It may only, you know, when you have Lambdas sitting there and they fire based on events, they only execute code when needed. Hey, but what code doesn't only execute when needed. I mean, if your code executes when it's not needed, isn't that a bug? Scaling automatically, if you're looking at a resource constrained edge thing, and some of that low end hardware we were talking about, Raspberry Pi grade or even Nook grade, is so low that effectively you may not have the miracle of elastic scalability in the sense that you can code apps as if they can go bump off other less important things and get scale only when they're needed. So to me, even though I've been nitpicking this quote and picking on the red stuff, there is some value in here. The key here with Lambdas at Edge are event-driven execution. Whether you get charged for it or not, it's really cool that maybe you can have a new coding style based on event triggering. So the key here is I've added a few more quotes from the Lambda page. You use it to run your code in response to events such as changes to data. And you can also build serverless apps composed of functions that are triggered by events. I think potentially that kind of model is really valuable, not because of cost savings, but potentially if you go with a model where you pre-stage your Lambda, quote, serverless to cut out the startup latency, you can build some apps that really can deliver kind of a new class of value. And I can tell already, and I'm presenting this for the first time, I might want to rearrange my slides. So the order I have this is that Serverless at Edge has this issue of maybe being too fat. Knative is potentially pretty resource intensive because it demands Istio. And I'm not sure that you can actually run Kubernetes plus Knative on something like a Pi 3. A Pi 4, probably you could. OpenFast is a thinner one, and clearly you can run it on a Pi. I believe Alex Ellis's blog actually has instructional material on installing it on a Pi 3. But the biggest issue of serverless is this startup latency, the 0 to 1. If you really don't pre-stage the serverless backend and have it ready to go when called upon, you can be dealing with issues of startup latencies of a second or more. And if you've moved out to Edge or are hosting apps at Edge because of latency challenges, this probably isn't going to work for you. So the other thing that I'm concerned about with serverless at Edge, if you're not ultimately just feeding a data pipeline all the way up to a public cloud, is that Lambdas by design are stateless. They don't maintain state, yet from the aerial view, any practical application is going to need resilient state storage, even if it's only to act as a cache as the data moves to a public cloud. And I say that because if if you can guarantee a continuous pipeline to the public cloud that never breaks, where you never have network outages, fine. But the stories I've been hearing about from most people trying to deploy out at Edge is one of the biggest problems is intermittent bandwidth and this need to cache things. And if the data is really important for a lot of use cases, you're going to have to deal with storing that thing at least temporarily, if not indefinitely. And if you're going to make use of this event-driven model, there needs to be some solution that addresses state. And it could be something like, standing up an equivalent of S3 storage on premises, but you're going to need something. So to me, the biggest value of serverless is, you know, there's a lot of stupid hype about IoT being the value of connecting every sensor and controller up through the public internet. And I submit to you that the real value in edge processing is actually instead something more analogous to serverless. But instead of removing costs, which is that story of you only pay for these things when you use them, we're going to remove something else that's costly and induces latency. It's not serverless. It's actually what I'm going to call personless. If you look at the history of compute, you go back to the 60s, and compute was very far removed from people who got value out of the compute. You know, the 60s was that was the decade of the IBM mainframe, where major organizations had one of these mainframes. And it was often processing paper records that get collected out at retail locations, got transcoded by humans on key punch machines, ultimately producing reports and value. But for the average employee or human in those organizations, they were very far removed from that mainframe. In fact, the mainframe was generally in a locked room with a raised floor. And that was the IT lifestyle of the 60s. Mini computers came about in the 70s, and they were cheaper and something that could move out to non-central locations because they were affordable and didn't require customized buildings to host them. So the move from mainframes to mini computers, I would contend, was a move of compute moving closer to the humans to do service for them. Once again, you move a decade after the 70s mini computer era. The 80s was the advent of personal computers. And the personal computer potentially moved all the way out to households, but certainly to even the smallest business locations. And sometimes these computers were shared. You know, in a household environment, the computers were still expensive enough that members of a household would actually share one computer. Often small businesses or branch offices of large businesses would not have a computer per person. But eventually, as we moved to the 90s, the cost of those personal computers moved down to the point where people sometimes had a computer when they went to work, provided by the employer, another one when they went home, and maybe multiple family members in a wealthy household had their own computers. Finally, moving on to cell phones, that compute became portable and became even more ubiquitous. But the trend was that compute moved down closer and closer to the humans. Well, I would contend that the trend for edge going into the next decade is actually going to be for the computers to finally leap ahead of the humans. When I say that, is that crazy talk? No. The humans now are a big, if this information has to be collected by a human reacting to something, it's a big latency impediment. And the trend with things like machine learning, image recognition, is actually not to have human beings watching analog camera feeds, but to have AIs and machine learning taking the first bite at these data flows, spotting the anomalies or deducing value out of these before the human even sees these data flows. And I think serverless has the potential to be of great value here. But at edge, it should be called personless, because what you're really doing isn't replacing the server. You still have the server if you're the one staging it on your own edge hardware. But what you are potentially doing is building the equivalent of robots that maybe do difficult work for humans in a better way than the humans can, or maybe outright replace humans. You know, it's not especially a rewarding job to be somebody looking at the security cameras for an 8-hour work shift. And maybe those, you know, maybe what's going on here is the computer actually turns this into personless. So I think that concludes what I was prepared to show here, but I'd be interested in hearing the reactions of how you, my test audience, thought that went.
Yeah, it's really great. The time-wise, a little bit longer than maybe just my interruption.
Right.
It's more than 25 or maybe 30 minutes.
Yeah, that's too long because I have to let Cindy talk too. So,
yeah.
But I'm just interested in whether, you know, to my knowledge, I just started thinking about serverless at Edge after getting prompted by Kilton. So I even want to know what you think of that idea. Does that make sense? Because
yeah, it does make sense. Actually, we are thinking about if we should integrate Knative into Kubernetes, and because we are looking for collaborating with other open source projects, or bring the serverless ability or skills to the edge. It's an interesting topic. I think only one suggestion, say, if you have any more concrete example, say, you talk about the more personalized and to to deal with the data at the location, right?
Yeah, I think I probably have to lose one. Either I can go into hosting serverless at Edge using the existing solutions like Knative or OpenFaaS, or I can talk about kind of this philosophy of serverless not really being about serverless so much as just the value of event-driven being used as a replacement for people. Which of those two do you think is more interesting?
I think the second one, the one without pointing out any suggestions, because I think it fits your talk more properly, because your talk is not to advertise or any directions, right? You just gave the trend or the analysis. That's only my opinion, say. So without pointing out any concrete, any particular project,
yeah,
that's better.
Not only that, I can't go very deep. And like I say, I'm actually curious that maybe at a future meeting, if you've been looking at Knative, I'd like to know from what you've learned, what the scenario is for Knative at Edge. Am I right to speculate that that's a pretty resource intensive solution? The reason I say it is I gave a presentation on Istio at Open Source Summit a year ago and gave a demo running on my laptop. And I just know that took an awful lot of resource on my laptop. I was lucky I had a 32 gigabyte laptop because I'm not sure that was really viable on a smaller one.
Yeah, the thing is, in our thought, in my case, I'm looking for is just like you said, a little bit more powerful edge, or like MEC edge or enterprise edge. Not for the IoT. The IoT one, we see they have a limited resource, right? They have different purpose. But the edge computing, you have from its big variations, right? From very small edge to very big edge. So, there's so many different configurations. So you cannot.
I saw Tina came, and I think I'm going to stop this because we didn't give her enough time last time. I don't want to do it again. So hi, Tina.
Hi, I'm here. Sorry, I'm late. I didn't know. Am I scheduled for today? I'm scheduled for the morning time.
Oh, okay. So if you wanted the next one, that's fine. We don't have it. We'll just roll it into that, especially in fairness, since you didn't know this was the slot. So it wasn't clear to me which of those you wanted. Sorry.
Oh.
Okay. So sure, you can have the morning slot would be in about 2 weeks. So let's plan on that, especially because we got somewhat light attendance this evening too.
Yes, that's what I'm thinking. Yeah.
Okay. So yeah, I'll put you on the calendar for the next one, and you're welcome to stick around anyway and listen if you want. What I was doing, and maybe you caught the tail end of it, is that I was doing a test run of some material I was thinking of putting on for KubeCon Europe. So I was just trying to give a presentation on serverless at Edge. So Yin and I were talking about, I'd be interested in your perspective when it comes to Knative too. You were saying it was really only for certain classes like MEC. And I think you might be onto something there in that really if you go Knative plus Istio, and I think at this point the two are really intertwined, you're looking at HTTPS, and for kind of the device edge, a lot of that is more MQTT centric or other protocols. And maybe you just leave it at those other protocols until you can get up to a gateway node that could process it and maybe translate it into something you could turn into Knative. But
yeah, the one example we used to run is more like a JavaScript. You have about a couple lines code. Basically, for example, you turn on and turn off the smart speech.
mm-hmm.
So that use MQTT protocol, and that's only we were running is use the Samsung's the what's the engine the real I forget what's the JS engine it has. It's really small.
Mm-hmm.
It's only have the compiler is only about less than 20 kilobytes or something in memory consumption. So that's feed that it does feed the needs, and also you can I mean in the principle it's kind of a service, right? The event trigger and only trigger a few
in a way a lot of those tools built for MQTT are similar to serverless in that they're event driven anyway, right?
Yeah, the thing is, do you want a complicated serverless framework, or you already, I mean, does fit in the principle is a serverless, right? The event trigger and the function only run with that data, and it's because it's very light. It's already a kind of a serverless.
Well, the other thing I got into when you literally took Lambdas hosted at Edge, if you could do that, is the fact that they're stateless. And once again, I contend that for some of these edge locations, you really need state somewhere. So maybe some other technologies are better suited. You need the state even if we're staging. Some of these transports inherently are capable of queuing, where they not only will handle events, but maybe keep them possibly resiliently enough so that things don't get lost when you have temporary network outages.
Yeah. So, yeah.
So as you look at serverless like Knative, is there any ongoing work integrating in things like Kafka into KubeEdge as well to go with models of kind of continuous event flows?
Yeah, the Kafka, because we tried that, but even the slim version is still too big, because we were targeting, as I said, we targeting as a 256 megabytes memory only. So we have a mini Flink, but it's for the stream data processing. It's different from a Kafka. It's take about 130 megabytes. I mean, so if we only run the small functions, we need to still, leave a few extra space for the user applications. So for the Pi, but the 1 gig memory is pretty generous already. So
did you ever do any assessment of how big the footprint is of Knative if you had to go
No,
there?
we haven't. So that's we are doing. It's our roadmap. So I think by the end of this year, we're going to have another 2 releases. We are probably in the next release as October release or November. That will be November as we are releasing now. Next release it's in our roadmap. We are to investigate. Hopefully by the end of the year, we are going to have some integration to show here.
And I'm just curious, did you ever evaluate the OpenFast to see if that might make more sense or be useful? Because I believe that
we haven't started yet, so this still on the table. Everything is on the table. Knative, OpenFast. Probably it's all depends on the adoptions, right? We want to pick the one adoptions and leave the generic interface for other people can switch off. Yeah, that's the plan. Yeah,
I think some of the issues with some of these technologies are just how healthy their open source communities are too, where you know, there's enough going on that they're going to stick around and grow.
And it used to be a lot of a service con, and I don't know, it's kind of, I mean, getting the noise is getting weaker and weaker. I mean.
So Tina, if you're still there, I'm just curious on Akrano if there are any people on that project who are pursuing serverless solutions.
Yes, we have a serverless blueprint on the network cloud blueprint family.
Okay.
AT&T was leading it.
Okay. Yeah, I'd be interested in hearing about that then. And I think others would be too, if that isn't too advanced to put into your presentation when you give it.
Yeah, I can talk about that. It's saying it was in release 1, but for some reason, the code was there, but it didn't participate in release 2 and 3.
Okay. And then for that serverless, is it based on some existing project like Knative, or is it something that's entirely within Akrano?
It integrated the upstream component from CNCF.
Okay. Okay, I think at this point we've covered our agenda. Does anybody else have anything they want to throw out there and talk about? I think before the recording started, and maybe some of you joined, Yin mentioned that the Cube Edge is up for vote with the TOC in the CNCF for advancement. So.
Yeah, Tina and you both already give a +1, but
yeah, +1 already. Yeah.
So we got 5. I think we got 5. I think Saeed will give another one soon. So we still need 2 more.
You can ask Liang.
Yeah, Liang Sheng already gave us +1.
Okay, cool.
We are looking for Li Xiang, so.
And then if you want, do you have sessions on Cube Edge at, I know you do at the Cloud Native Con China, because I saw 2 of them, but do you have any at the Europe event?
We do have one, but that's only for intro sessions.
Okay.
We usually have one for intro, one for deep dive. So the Europe, we have the intro to try to get more people involved. In the North America one, usually a deep dive to have a more technical more technical details. So
I'm curious, how do the current users shape up geographically? You know, like Asia versus North America versus Europe for Cube Edge usage?
It's Asia is the most. Then Europe we have a few, and also a few evaluated. For the US, only the IBM is evaluating. So we only have a limited print in the North America.
Mm-hmm. Okay. Last call. Does anybody have anything they want to discuss? Otherwise, we'll end this 5 minutes early.
Yep. Thank you. Now from me.
Okay. Thank you, everybody. I'll shut down the recording, and that's a wrap.
Thank you. See you next time.
Have a good night.